Okay, so now that we understand the imaginary number I, let's see another way that's used in simplifying square roots. So before, if I asked you to simplify, and let's actually write the word simplify, it's important here. If I asked you to simplify the square root of negative 25, well, I'll make a note. Before we were working in real numbers, right? In real numbers, the square root of negative 25 is not real. It's not a real number. So that's what we would reply with before. It's not a real number. However, in complex numbers, or using the imaginary numbers, in complex numbers, the square root of negative 25 equals, you can split the negative as a negative 1 times the square root of 25. And now the square root of negative 1 is I, the square root of 25 is 5, so you can say this is I times 5. And we typically write that as 5i. So in complex numbers, the square root of negative 25 is 5i. Okay, so here we're multiplying the square root of negative 10 by the square root of negative 5, multiplying two square roots. And so what we've done before is we were able to, this is wrong, I'm going to write it over here to point out what is wrong about this. You cannot put both of those underneath the same square root and then say it's the square root of positive 50. That property where you put both of them under the same square root only worked if each of these were real numbers, right? And they're not because they have a negative underneath the square root. So neither one of those is a real number. So you cannot do this when you're working with complex numbers. However, you can rewrite it in such a way that you can separate the real parts from the imaginary parts. So for example, the square root of negative 10 is the square root of negative 1 times the square root of 10. The square root of negative 5 is the square root of negative 1 times the square root of 5. And now, these are the only two parts that aren't real. And when you multiply those, well, in fact, the square root of negative 1 is I. So you have I times the square root of, sorry, let's multiply those together. You get I times I, which is I squared. And square root of 10 times square root of 5 are both real numbers, so now you can multiply those together underneath one radical to get the square root of 50. So I squared is negative 1, so you have negative square root of 50, and now you can simplify the square root of 50, because it's a real number. You could break it down to 25 times 2, and the square root of 25 is 5, and the square root of 2 is 2. So this simplifies down to negative 5 times the square root of 2. So this is very interesting to me. Think about this. We're multiplying two numbers that are complex. They're not real, right? Because they have square roots underneath. But our result down here is a real number because there's no I and there's not a negative underneath the square root. So you multiply two numbers that aren't real and you end up with a number that is real. Okay, I want to write in the form a plus bi. You can write any complex number in this form. So let's say that we have 12 plus the square root of negative 18 all over 6. The first thing you'd want to do here is to simplify the square root of negative 18 by first pulling out the negative 1. So you can make it negative 1. Now you've got the 18. You could break that down to 9 times 2 because 9 is a perfect square. And on bottom you have 6 still. So you've got 12 plus. When you pull the 9 out, you get a 3. And the square root of negative 1 is I, and you're left with the square root of 2. And this is all over 6. Now whenever you have multiple terms over a single term, you can split these up over that term. So you can write this as 12 over 6 plus 3 times the square root of 2 over 6. And the I here, because we want it in the form a plus bi, you can put the I out to the side. And so now you can reduce each of these. 12 divided by 6 is 2. The 3 and the 6 reduce to 1 and 2. So you end up with 2 plus the square root of 2 over 2 times I. So a is 2, right? There's your a. And b is the square root of 2 over 2. So it's in the form a plus bi, and that's how you divide in this case.